temperature. T1 greater than T2. What is L? L is the length along the axis. Let K be the thermal conductivity. Now I want the thermal resistance of this tapered rod or truncated cone. Anything? How to proceed this one? So what is the basic method again? How the heat will flow. So these are insulated. These are insulated. So how the heat is permitted to flow lateral. Okay, this called like a lateral surface. This called like a slant surface. The slant surface is insulated. This at higher temperature, low temperatures. How the heat current will flow in this direction. It will flow along x-axis here. Then how the elemental structure? We should assume the elemental structure in such a way that the heat current should be directed perpendicular to the disk. Okay, no. So this is dx will take it at a distance x. Let r be the radius of this one. K is the thermal conductivity. Let me write it here. Okay, now what is the resistance of that elemental disk first? dr is equal to thickness of this dx, K into area of cross section pi r square. Can I integrate? If I go for integration, what is the thickness? Dx is thickness here. Small r is radius. Then what is thermal resistance? dl by K into area of cross section. So dx by K pi r square. What is the problem here? Okay, this unknown thing. Here two variables are there. X and R both are variable. You assume one more disk here. If you assume one more disk, what is the radius of that? Will be variable, and even the position of x is varying. So what is here? Both dx and the small r are variable. So when you can integrate, when unknown and one variable should be there. Both x and r are variable. We should make it one variable. Okay, what shall I do? Already such things we have discussed in elasticity. I'll go for here a triangle. I'll notice a triangle here. B minus A. This will be R minus, or so like a B minus R. This is X. This is L. Sorry, R minus A it is a. This distance, how much it will be? This is A, this is R. So what can be this distance? R minus A. What about this? Will be, this is A, this is B. So B minus A will come here. Okay, from this triangle, tan alpha. Tan alpha. R minus A by X equal to B minus A by L. R is equal to so what shall I replace? You can replace R or you can replace X, anything. Okay, let me replace the dx, that one. So if I differentiate this, dr equal to, let me replace dx here. So this dr is equal to 1 by K pi R square. Dx will be L dr B minus A. This rewriting K pi B minus A R to power of minus 2 dr. Okay, let me go for limits. What should be the limit now? Any limits can I take it? Okay, look at smaller. Smaller is the radius of that elemental disk, no? So what is this? Resistance of? This is very important. See, the whole problem revolves around assumption of things like this here. That's why I'm just highlighting that one, because that is very important. Once you are sure, then you can proceed everything perfectly. No, whatever the limits here. So at x equal to at smaller, so what is the radius? Here it is how much it is r. At left hand how much it is a. At right hand how much it is b. The radius is B. Therefore, what we can write here, the limits will be A to B. So therefore, this R is equal to L K pi B minus A, R to power of minus 1. Minus 2 plus 1 will be minus 1, A to B. Minus 1 by B plus 1 by A. So there's everything. How much will end up? You have to remember this formula, very important. You can't derive this in exam. See, I'm telling this one, some of you are so lazy that, okay, you just read and forget. See, this is what called as hard work. So if you remember this formula in exam, it will be very easy because the questions that will come in exam will be based on this formula. So a student must learn. He should have a memory. Without memory, not possible to get a better rank in advanced. Many will say advanced is based on thinking ability. What all you read, if you don't know how tell me what you do. What all you read, what all you read, if you forget everything, what you do in exam? Not possible, no? So the minimum memory is a must. What is the minimum memory? Like, okay, thermal conduction. For different shaped structures, what is the thermal resistance? You should know what is the method to determine and how much it is. Like this 10, like center of mass of a cone. Center of mass of a cone. Okay, then center of mass of so many structures are there. If you know them, it will be very easy, no? Directly you can enter into numericals. The same requirement is here also. Okay, no, so this is about the resistance of this one. So I'm interested to know the temperature of this one. How to get the temperature of this? Let T be the temperature. Here is what the thinking based numericals will start. This is about mathematics, no? I want the temperature of the rod at a distance x along the axis. Because the left hand is at temperature T1, right hand is at temperature T2. What can be temperature at this particular point? At a distance x or at a distance r, radius is r. What I do is like, I'll just break up this rod into two parts. See, this is what the tricky problems will be there. So what we will try to think in terms of mathematics, but here already you know formula, that formula should be applied properly. Okay, what is the question that is asked? Shall I break up this into two parts? Is it okay? This one. So what is asking? At a distance x. What is the radius of this? A. Radius of this is r. What is the temperature at this particular point? So here temperature is T1, T2, temperature here T and T. So what is the radius of this? This is r. So what is the length of this? L minus x. The structures are there like this. A simplified approach, the same, actually that structure only, I'm just breaking up into two parts. And then what about the heat current? What heat current flows in the left part? Same heat current will it flow? Because how they're in series, no? Will I agree? So this is according to our resistor concept, what we do. I'll magnify so that you can see things clearly. So from equivalent circuit diagram, So shall we put it like this? This is resistance R1, this is resistance R2. Here temperature T1, this is T, this is T2. Can you remember we have done yesterday, no? Like temperature of junction, the similar thing is what is being asked here. Same heat current, same heat current has to flow. What heat current is there? The same heat current will flow here. Why same heat current? They're in series. What is the expression for temperature of junction? So here H is equal to, I'll start from here mathematics. H is equal to H. What is H is equal to? Heat current is equal to temperature difference. T1, T minus T by R1, T minus T2 by R2. What are R1, R2 will substitute. What is R1? Resistance of the left part of tapered rod of length X and the radius will be A to R. Shall we use this formula? X by K pi A into R. This should be equal to T minus T2. Remaining part of length is how much? L minus X by K pi R into B. So K pi R get eliminated. K pi R gets eliminated. So this will be T1 minus A by X is equal to T minus T2 here B by L minus X. So solving for T will get the required answer. Okay, let me simplify this. TAX plus TB L minus X. T1A L minus X, T2BX equal to TA L minus X. I wanted expression for temperature, no? X into L minus X in numerator will get cancelled out. We'll shift it here so that it will be. Okay, the discussion is this one. We have started the discussion. Okay, able to see completely, no? Okay, let's solve for T, no? So this will be T1AL T2B minus T1AX by A into L. Okay, what is the temperature at a distance X? You can use this method. Check calculation 1. Even if you remember this formula well and better, you can do things very easily, no? Like this, you can calculate the temperature at a distance X or no, sir, at a radius R if they give. Okay, now replace using this formula. So at a distance X instead of this one, if they give value of in terms of R, okay, write X value here. So at a distance R, what is the value of X you calculate, that you substitute here. Even at in terms of R also you can bring it. Now replace B minus A into X, B minus A, B minus A X, what pen can you write in terms of R and substitute. So you'll get even expression for temperature at a radial distance also. Please do work out all this. So many ways are there here asking questions. Okay, fine now. So can you now are we in a better position as we can find out now temperature at any point here 100 here 50 degrees Celsius. Then what is the temperature at any point on the rod? Yes, we can determine. Okay, now next, in the similar way. Now exactly the midpoint. This is 100 degrees Celsius. This is 50 degrees Celsius. So length of the rod is exactly at L by 2. What is the temperature? I'm asking you to find out. Thermal conductivity is K. Exactly the midpoint. What is the temperature? Will it be greater than 75 or less than 75? Now, who will answer? Or equal to 75? How to decide this? I'll take help of these formulas. What we have. I just wanted to know temperature less than or greater than, or shall we write equal to 75? Is it okay? What is only help? This particular formula is going to help here. So the only thing is which is going to help us here. Okay, let the radius of what are values if you want you can assume. The radius of this end is A, this end is B. What about the heat current? The same heat current will flow across both elements. Agree this. So let me call this as resistance of this part is Rx, resistance of this part is Ry. What is Rx? We can write it as. So let the radius of this will be R. Any formula for Rx? Just now we are discussing, no? L by 2, 4 pi K A into R. So from where the formula? K pi. 4 will not be there. K pi A into R. What is the resistance of the right part? Length is L by 2. K pi R into B. Okay, till here, no problem, all of you. Okay, what is heat current? Expression for heat current. H should be equal to H. Same heat current for they are in series. Rx and Ry are in series. Both the left and right part, they are in series. Let me proceed here now. So, okay, I think let me put everything in one place. Yeah. The why they are in series. Now let's get into the discussion. What is heat current? Temperature difference. 100 minus T by Rx. T minus 50 by Ry. What is Rx? L by 2. L by 2 pi K A R. T minus 50. T minus 50. So Ry, this will be L by 2 pi KRB. Or this will be very lengthy. I suggest you this will be really very lengthy. So instead of this again deriving all that B greater than A, can you just tell me which will be greater, Rx or Ry? Let me take mathematics into picture because it's just asking Okay, now Rx or Ry, which will be greater? Looking at this diagram,
Rx.
Rx,
Rx, Rx must be greater than Ry, as we know, Rx greater than Ry. So therefore, what you can write it as 100 minus t by t minus 50 is greater than 1. Okay, this will be 100 minus 50 is greater than 2t, or 100 minus 50 will be 50, 100 plus 50, sorry. So this will be 75 greater than 2t, or t should be less than 75 degrees Celsius. Will I agree? The temperature at the midpoint will be less than 75. What do we think? We think that 100 plus 50 average and 150 by 2. Okay, just look at the structure. It's not a cylinder, it's a tapered rod. In exams, you do get questions like this. Huh? Nobody will ask you derive. I'm making things clear. Students will feel okay, very good color diagrams are there, very nice integration. Who will ask you derive this? Do you get exams in mains advanced questions of like this? Derive, show that, prove that. Application questions will come. What are the application questions? The first one here. What is the temperature at a distance x? Then at the midpoint, what will be the temperature? He will not ask midpoint. So he may ask here temperature. Then you have to use that formula. He may ask you greater than or less than or equal. The mathematics is this one. Getting some picture. The different shaped rods. What is the thermal resistance? That's what we are discussing here now.